Hi guys, I welcome you to my channel. Today I'll be solving another question of the blind 75. This is the uh, construct binary tree from the pre-order and in-order traversal. So basically, what will be given? I'll be given a binaries. I'll be given a two tree called in-order and pre-order, and that will be in list form. So list basically in top the list in list form, and I have to create the binary tree out of using them or taking them as a reference, right? So let's understand the logic behind it, and we will do that. So here I'll just take an example in the blind paper of black Google Doc, Google Doc, yeah. I have Google Doc, right? I have two array in order and pre-order. I have two array in order and pre-order, in order and pre-order, right? So you see here, and this is my binary source tree. Like I am not, I can here. This is my binary tree 3, 9, 20, 15, and 7. So let me create a binary tree here. I can just use this array as it to represent binary tree because I can't draw here. So yeah, 3, 9, 20, null, null, 5, 7. So what is happening here? Now see, uh, we know that how pre-order, how we traverse pre-order. So it is root, then left, then left, then right, right? And in the in order, what how do we traverse? It is left, root, and right. Correct, na? Correct. So see here, we know that in the pre-order we have root 3, right? If we found root, all the left of the root is in left subtree, and all the right of the root is the in right subtree. Correct, no? So we found here 3, right? So 3, so what is index of 3 is 1, right? So 1, all the element which is before 3, or all the element from uh, 0 to mid plus 1, or 0 to mid, right? All the element from 0 to mid is in the left subtree, and all the element from mid plus 1 to the length of the in order is in the right subtree. Correct, no? So see here, it means that I found the root here 3, and all the sorry, I found the root here, and here what is see here, uh, what is see here, 9 is in the left subtree, and 15, 20, and 7 is in the right subtree. Correct, no? So there is nothing on the right, so we will go to the left. Sorry, there is nothing on the left, so we will go to the right. And again, so 9 is already printed, 9 is already taken and added here. We will go to the 20 here. How we will go to 20? So in order, we will use that mid is this one. So in order, all the element of 1 to, like including, I'm not like taking 0. Why? Because 0 is the root. So 1 to mid plus 1, 1 to mid plus 1, like 1 is here, right? 1 is here, and mid plus 1 is this one 2, right? So all element which is 1 to mid plus 1, here 2 will be excluded. So all the element on the 1 to 1 is in the left subtree, and all it, or after that all will be in the right subtree. So that's what we have added here. 20, 15, and 7 will be the right, and 9 will be on left. 9 will be on left. Correct, no? So left we have already traversed, there nothing, so we have printed left, and now we'll go to the right. So now we have 20 here. So 20 is the root, right? We assumed, we know that first element of the pre-order is the root. So we have reduced the, we have shrink the size of the pre-order from 5 to 3, just 3, right? So 20, 15, and 7, 20, 15, and 7. Now we have this 20. So I'll assume 20 as a root, 20 as a root. So first node of the pre-order is the root as well, right? So we'll go to the left and right. So let me find the index first. So you see here, from we are just ignoring 9 because we have already taken it on the left subtree. So we ignore 9, and we have this 3 and 3 as well, because 3 is the root. So we have 15, 20, and 7, right? now we have to find the index of 20. So what index of 20? 0 1. Index of 20 is 1, right? So all element which is before 20 it will be in the left subtree, and all the element after 20 will be in the right subtree. So that index here, index is 1, right? So index is 1, so 0 1, so 1 comma mid plus 1, that is 2. See this, when we do process, no, when we do process we are reducing the size of the this list. That's why here will be now, that's why the new index will be 0, and the mid will be the uh, new index will be the this mid will be the here. What is the mid? 0 1. So all the elements from 1 to 1, that is 15, will be on right left. All the element from 1 to length of the pre-order will be the on the right. The same, all the element that is 15 will be on left, and 7 will be on right, and here we have the binary tree. That's it, and that is the thing we have to do. So we just remember this thing, the root left right, and one more pattern here, how we traverse pre-order, root left right, and how we traverse in order, left root right, right. And when we are moving from we traverse pre-order, and we find the index, we find the root, and use that root to find the index in the in order, right? And all element of all element of the in order before root is will be called left subtree, and all element after the root will be called right subtree, right? This is how it works. Let me write the code for you. So what I'll verify first ki if root list is defined, or list is there. So if not list, not pre-order, and not in order, if both are defined, then only I will proceed, otherwise I will return none. Right, now I will try to find root. So root will be the pre-order of 0, right? Every time pre-order of 0, root is always the 0th element of the pre-order. Now we will try to find the index in the in order of that particular root. So I will tell mid index. So that basically this is the bridge to divide divide the list into the left and right. So this is mid index, and this is mid index. So I'll find in order dot index. Very interesting. You can find the index of the any list using in order dot index, and the value pre order of 0. That will give us the index of the list, like mid index. Now just we have to do root dot left, and we'll call the same function build tree. And in the build tree we'll create a new list, right? That is pre-order from where to where we have to take. So we will not taking 0, that is 1 1 to till where 1 to mid plus 1. So we will include mid as well in this here, and we will update the in order. So in order will be the from 0 to mid. So all the element we are not taking mid. Why? Because mid is already a root in order, right? Now let's do the root dot right. Root dot right will be the, I'll copy this pre-order. It will be the from mid plus 1 to all the pre-order element, and in the in order as well it will be the mid plus 1. We are not taking mid in any in order, because here root mid is basically a root. That's it, and we will return my answer, return root. That's it, guys. That is the code only. Okay, so it should be a square bracket, not a small bracket. So a square bracket, let me write a square bracket. Yeah, we have written a square bracket here. So I'll just replace mid with mid index. I have replaced it. Now submit it. What is the problem again? Int object has no attribute left. Okay, we have to create a root of this, right? Sorry, there's a lot of bug. Read node, 3 node. We have to create a root. We have to create a node, right? Then we can have left and right. Otherwise, it will not 3 node. Yeah, I think there's nothing more. If not pre-order and in order, I will return none. Otherwise, I will create a root using 3 node. I will find the mid index using pre-index for. Now we will build the left. We will the right. Will build the right. And we are not finding the range from where to where. See, I have tried the column. If I write the column, we will give the last of the in order. That's it. Let me submit it. Now it is done. Just analyze the root time complexity because I don't know. Let me see. So here mid index basically takes of n time. Probably it is traversing all the index and finding the root index of this root. This is mid index, and I am getting substring out of this. And I don't know how much time it takes to. Let me ask ChatGPT to analyze the time complexity of this particular thing. Uh, Analyze the time complexity of this function. Recursive call, and we are creating substring, that also count, right? We are creating substring, that also count. What is TC I have sent to you? Slicing each node will take 1 OFN. Total recursive call OFN. Since using processing each node, total time complexity of n square because n becomes equal and each takes OFN work. And index and slicing index, that is OFN square. And recursion stack take 1 OFN in worst case, 3 is exclude. So OFN, OFN. Yeah, so in this case we are creating our time complexity will be the OFN square. How? Because see here we are finding the index, right? It will take OFN. We are creating substring or sub array, that is OFK. But I assume this is OFN in the worst case. So OFN, 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 and we will take one of them, that is OFN only, and we are looping it. Basically we are doing recursive call for each node, so that is OFN. So OFN into n, that is n square, and time complexity basically we are stacking everything on the stack. So that is the so there if there is n element, the time complexity will be n. So that is, sorry, space complexity will be the OFN. So time complexity will be the OFN square, and space complexity will be the OFN. So we can optimize it, definitely we can optimize it, but let's do this first. After that we'll do optimization of the question. So thanks for watching, and I have showed up again, and I will doing again and again until I get job in a big tech company. Thanks for watching. Bye bye.